It's hard to remember a time when satellites didn't play a big role in our lives, and satellite imagery wasn't part of a meteorologist's toolbox. In fact, tomorrow is 50 years since the launch of the first satellite, Sputnik 1, by the Soviet Union, an event that not only changed the scientific world, but had huge geopolitical implications as well. Sputnik was a simple sphere not quite 2 feet wide and 200 pounds. 3 months after Sputnik, the U.S. launched its first satellite, Explorer 1, and the space race was on. Later that year, Congress established NASA, and in April 1960, the U.S. put the first successful weather satellite in orbit, Tyros 1. Its pictures were grainy, and it only worked for 78 days, but it demonstrated that satellites could be used to survey the weather from space. Today's weather satellites come in 2 types. Geostationary satellites are parked 22,500 miles above the equator and move at the same speed as the Earth rotates, so they always have the same view of the Earth below. Thus, they're ideal for creating cloud animations. Now, the U.S. geostationary satellite program is called GOES, which stands for Geostationary Operational Environmental Satellite. 13 GOES have been launched since 1975, and 5 are still used today for meteorological purposes. GOES 11 and GOES 12 monitor the U.S. and surrounding oceans. GOES 11 takes care of the East and the Atlantic, GOES 12 the West and the Pacific. GOES 10 assists GOES 11, particularly with South American views. GOES 9 is on loan to Japan to replace one of their ailing satellites and is positioned over the Western Pacific. And finally, GOES 13, which was launched last year, is stored in orbit just in case one of the other geostationary satellites fails. Now, GOES satellites have a couple limitations. They're very high up, so their best resolution is about 0.6 of a mile. This means that clouds smaller than about 10 football fields across aren't resolved very well. And being over the equator means they look at the polar latitudes on edge, so geostationary satellites don't have a very good view of the higher latitudes. The second type of weather satellite is the polar orbiter, and it helps on both counts. Polar orbiters track north and south over the poles as the Earth rotates below, so they see all parts of the globe a couple times a day. They're only about 500 miles up, so they have better resolution, around 1/10 of a mile, so you can see much finer detail. Check out this image from back in early March. You can see the subtleties of the snow cover over Pennsylvania and western New York and cracks in the ice on Lake Erie. And how about this one of the roiling clouds in and around the eye of Hurricane Katrina? Ironically, one of the most famous images of Earth from space didn't come from a weather satellite. It's this one taken from Apollo 8 on Christmas Eve 1968 as it emerged from behind the moon and saw the Earth rise over the horizon. This has been called the most influential environmental photograph ever taken. Paul Knight will be back with the extended forecast next.